Greetings, welcome to Patch a Day number 8. Today I'm going to make something which freezes audio using an FFT. Just to reiterate, I'm going to run out of ideas on these, and so if you message me with any ideas you have for patches or something you're having trouble understanding in the whole Max MSP jitter world, please let me know. Yeah. All right, I'm going to start with an easy ADC and an easy DAC because I'm going to use my microphone input and I'm going to use the audio output so I can hear what's going on. And then I'm going to make something, a new patcher in a PFFT. And if we create a PFFT and look at the max window, um, which we can see here, says requires patcher name argument. That's because for a PFFT to do anything, it needs to have an abstraction loaded into it. And let's create that abstraction right now. So Command N or Control N on a PC, make a new patch, make a new patcher, and the first thing an PFFT needs is an FFT in. And again, if we create one of those and look at the max window, FFT in must have an integer as first argument. That's just because it needs to have an inlet number. So it's the first inlet for the PFFT, and then another, we need an FFT out as well. All PFFTs, assuming you're going to do FFT, communicate to the outside world, need FFT in and FFT out. We look at the outlets for the FFT in. It has a real, it has an imaginary, and it has a bin index, which goes from 0 to 1 less than whatever size FFT you desire. You make that choice out in the PFFT. Okay, I'm going to record these real and imaginary values into a buffer. And to do that, I'm going to use a new object here called poke, and I'm going to poke, give it the name of the buffer, and then I need to tell it which channel. I'm going to make a stereo buffer called snacks, and I'm going to poke the real into the first channel of the snacks buffer, and then I can just hold down my option key and drag that over to create another copy to poke the imaginary into the second channel of that buffer. The other thing that I'm going to do is read back the data from those buffers, and I'm going to use for that an object called index, and I'll type snacks again with again channel 1 to read back the real, and again I can duplicate that and read back on channel 2 for the imaginary. And I think I'm just going to take this here index, and I'm either going to send it to the part where I'm writing to the buffer, or I'm going to send it to the place where I'm reading from the buffer. So I'm going to use a gate where I can send it to one of two places. So a gate tilde, because that is a signal coming out of that index outlet here. I'm going to gate and send that index either to the poke objects, or I'm going to send it to the index objects to read it back out. Poke to write, index to read. All right, and I'm going to want to have something to control. Actually, we can hook up these indexes to the output. I'm going to want to have something on the outside world, outside world patcher that will help me choose whether I'm writing or reading from that buffer. So I'm going to make a receive called RFFT freeze, and because this will be 1 to open up this it'll want to be a 1 to open up this outlet and a 2 to open up this outlet. If it's going to be a toggle out there on the outside patcher, I'm going to want to add 1 to make that work, to toggle that gate. Okay, that looks finished to me, and I'm going to save this in somewhere where I'll remember where it is. FFT Freezer, and go back to my original patch here where I started the PFFT and create that, put that name in there. A couple other arguments I'll put into the PFFT is the size of the FFT 1024. It has to be a power of 2. That's a nice sort of middle range number there. And the number of overlaps in the FFT, which without a huge amount of discussion, we can't really describe what that means. But in the max window, again, it can't find the patcher. Actually, it would have an outlet if it did find it. So we need to save this in the same place as we saved the FFT Freezer. Okay, so FFT Frizz. Oh, maybe I'll call it my FFT Frizz so I don't just make the mistake of confusing it with the abstraction. And you'll see it didn't automatically create that. That's not abnormal. We need to reinstantiate that. Basically, just change something. I mean, don't need to change something. Just retype the number 2 in there, for example. Now that it has an outlet, I'm pretty sure that that's now working. The other thing we need out here is we never made this buffer called snacks, so I guess we'll need to make a buffer snacks. Oh, that's not how you spell snacks. Snacks with let's say 1,000 milliseconds just to go over the top. It doesn't need to be that long, but hey, it's not going to do us any harm. And then number 2 for the number of channels. Okay, and the other thing I suppose we're going to want to make is a send FFT, what did I call that? Freeze? Something that simple. So yeah, send over here with a toggle attached to it. Then assuming we can hook this up just like so. Sure, left channel's fine. And then the outlets, this thing should work. So yeah, let's see if it freezes. Hello, does it freeze? Maybe not. And why isn't it working? Work all day. Oh, I didn't even turn this on. It was on. Hello, Helly. So I guess the thing that you'll notice is that when it's turned off, it has this kind of crunchy whoa sound, and I guess the really simple way of getting rid of that is just to gate or multiply this output so that when it's off, when the FFT freeze is off, it just doesn't send anything through. That's all that. You've probably done this about 100 times before, so we'll pack that over 20, let's say, to stop it from clicking when we turn it on into a line, tilde. And that should be all groovy. Alright, so now it freezes. Hello. Now it freezes. Then I can just stop and stop this wherever, and it hears what I said. Alright, so that was patch day 8, and I'll see you in number